welcome to the Energy Question with David Blackman. I'm your host, David Blackman, and my very special guest today is Cindy Taff, the CEO, Chief Executive Officer of Sage Geosystems, Texas-based company that's working in the area of geothermal energy. And this is a really exciting one for me to do because it's something I've always been very interested in personally. So welcome to the show, Cindy.
Yeah, David, thank you for having me on. I really think what we're going to be talking about is going to resonate with your listeners because, as you know, geothermal energy is a natural segue into renewables from oil and gas. So happy to be on.
Yeah, it really is. And it just makes so much sense from an energy and policy perspective. And I know you're going to be able to give us all the details why it makes sense from a business perspective too. Before we go into the Q&A, though, I want to give you a few minutes to talk about your background and the mission, the business objectives for Sage Geosystems.
Yeah, no, absolutely. So my background, David, I've got over 35 years of experience in the oil and gas industry. My last role was Vice President of Wells over Shell's global unconventional assets, which included assets in Canada, South America, China, and even Ukraine before we got out of Ukraine. So what I'm proud of is I led my team to systematically reduce cost over about 50% over about a 5-year period. And this is during a time where the scope, so both lateral length and number of fracs were increasing. So I'm currently, as you mentioned, CEO of Sage, and really we're excited to be using our oil and gas background to actually bolster the geothermal industry. So happy to be in geothermal. And I want to mention we're also doing energy storage. So that's something that hopefully we'll have time to talk about as well.
Why don't we start with that, energy storage? What are the mechanics of that related to a geothermal project?
Yeah, so, David, right now we can actually deliver long duration energy storage solutions at a cost that beats pumped hydro storage and lithium ion batteries. So believe it or not, pumped hydro storage, so where you pump, water from the bottom of a mountain to the top of a mountain, that actually accounts for about 90 to 95% of the storage around the world. So we can actually beat those costs now. And if you think about lithium ion batteries, where you have to depend on lithium, there's a huge dependency on China. Right. So we can do that. We can do that now. So if we are able to put our energy storage together with solar, we can actually generate baseload power. So solar plus our energy storage gives you 24/7 baseload. And we've got a line of sight to actually beat combined cycle peaker plants at $2 an MCF. So we're excited. We've done some tests in Starr County, Texas. So I'm really excited about what we're doing, and we're looking to do our first demonstration pilot plant in first half of next year.
Well, one of the things that's always I won't say confused necessarily, but struck me is the potential for geothermal has always been pretty enormous, but it never has really scaled up in a big way. As you note on your website, current geothermal activity has been located near dormant volcanoes, basically in those areas and in very isolated parts of the country. Talk about the factors that have conspired really that have prevented geothermal from scaling up in a significant way over the past decade.
So the areas that you mentioned, David, that is called conventional or hydrothermal geothermal. So of course that's been around for over 100 years. The challenge is that you need to be, to get the geologic characteristics, you need to be either near a volcano or near the ring of fire. And so it represents only about 2% of the geothermal resources around the world. And so what represents a bigger resource base and really the ability to put geothermal in more places than just these geographically limited areas like, Iceland or, geysers of California, would be a formation that is hot, but it doesn't have the water that will naturally bring that heat to surface. So it's called hot, dry rock. So it's contained in formations that the oil and gas industry has drilled to these depths for many, many years. So for example, the Starr County test well that we have was drilled in 2008 to a depth of 19,000 feet and almost 500 degrees F. So that's plenty of heat right there
Yeah.
to have a commercial installation.
Yeah, and that's all very technically feasible. I mean, with current technology, right? We've already drilled wells. I know we've been drilling wells in the Madden field in Wyoming, 27,000 feet in the United States. So none of this is beyond technical feasibility with just current technology, right?
That's correct for drilling the well. Now, what we're focused on is how do you cost effectively then harvest that heat out of the earth and then bring the heat to surface and then cost effectively convert that heat to electricity. So that's the challenge. And it's actually the challenge that the EGS industry has faced for about 40 years. And so most of the industry uses what they call a two-well EGS system, where you drill one well, you inject, you drill one well, and which is going to be your injector. You drill another, which is going to be your producer, and then you create a frac in between those wells. And so then you pump water into the injector and then move it through that frac and then produce it out of the producer. And some of the challenges with this two-well EGS system, one is cost, because you need two wells. The other is really the ability to connect that fracture between the two wells.
Yeah.
And then once the fracture network is actually created, it takes a significant amount of pump pressure or energy, parasitic energy, to pump water from one well to the other. And then there's actually a tendency, as you know, being in the oil and gas industry, there's a tendency for that water to follow the path of least resistance. So it tends to short circuit and not use that entire frac as a heat, basically surface area for a heat exchanger. And so those are some of the challenges with the two-well EGS system. So what Sage is doing differently is we're using a single well, so your cost is going to go down. And then we use what we call a cycle of injection and production. So very much like huff and puff in the oil and gas industry. So we've been able to overcome some of those challenges that the two-well EGS system has had for many years.
Is it a strictly vertical well, or is there a horizontal lateral involved too?
Our test well in Starr County happens to be a vertical well with a single fracture, but what we will be testing is the ability to drill a horizontal well, install multiple fractures, just like in unconventionals, and for those fractures then to be additive, not only in surface area where that heat exchange takes place, but also in the pressure energy that you get out of those fractures as the fractures will close on that water when you're pumping that water to harvest the heat. And not only do you have the heat energy from that water, but as you can imagine, you have the pressure energy from that water that you get to harvest and turn into electricity.
Right. These are strictly conventional formations you're tapping into?
Yeah, David, that's what's interesting. So you almost have to take your oil and gas hat and put it on upside down. So we are targeting formations that are low to no permeability, low to no porosity. We're not wanting secondary permeability from fractures or faults. We're actually wanting something that's very tight so that when we pump the water into the fracture, the water stays there. And then, so what we do is we pump the water into the fracture, we close the wellhead valve, the water gets stored in that fracture under pressure. If it's hot enough, it also gets heated. And then when the energy demand peaks, you open up the wellhead valve, and that fracture is wanting to close naturally on that water, and it jettisons the water back to surface under a tremendous amount of pressure and force.
So talk about every industry like this has pretty significant infrastructure challenges, right, ahead of it. A new industry that is a cutting edge technology like this. Talk about the kinds of infrastructure requirements and challenges you'll be facing in bringing this all, in being able to scale this kind of an operation up.
Yeah, so that's a great question. So I would say that one of the main infrastructure challenges is actually if we're wanting to connect to the utility grid, which our technologies do not have to connect to the utility grid. We can have microgrids or what they're called island grids, which are
Right.
behind the meter and servicing an industry or a facility that needs energy and they don't want to be on the grid. So, for example, the military wants this security of supply, but if we're wanting to connect to the utility grid, one of the biggest challenges is the current wait time for getting that connection, and also some of the equipment. So, for example, transformers and switch gears, just the lead time to get those are 12 to 18 months. So I think that's one of the biggest challenges that we have. Other than that, we're drilling a well using existing off-the-shelf oil and gas equipment and people, so that's pretty straightforward. And then our power plant equipment is, I mean, we do have some proprietary technology that we're using, which includes a supercritical CO2 turbine, which we're actually going to be testing the prototype in a matter of a couple of months. But other than that, it's pretty straightforward. So I would say the biggest infrastructure challenge is getting connected to the grid.
Yeah, you mentioned transformers. I just as an aside, I've talked to the presidents of several of the power industries trade associations in recent weeks about that. That is a big issue facing our country, is the supply chain muck up where transformers are concerned. I wonder also, for an application like yours, we have this issue in the Permian Basin, talking about the grid, where there's a shortage of transmission and really electricity available in the Permian Basin of all places. I mean, I wonder, is there a potential for geothermal to kind of, be able to establish a microgrid to power the oil patch out there in the Permian and help these operating companies acquire electricity from that kind of a source rather than having to wait for the grid to come out there?
Yeah, David, absolutely. So, for example, we're working with an oil and gas company in California that's actually starting to focus on carbon capture, and they're wanting electricity behind the meter, and they also need heat. So, as you can imagine, we can provide both electricity and heat, and there's a lot of industrial applications that need heat. So, direct air capture needs heat. But yes, we can create that island grid or microgrid behind the meter and provide electricity and heat for different operations. So that's definitely, I mean, so there's a question, if you think about it, about the utility grids need updating, they need upgrading. So there's a lot of money that needs to be spent doing that. But then you can also start looking at distributed power. So we can definitely provide the power where you can direct it to a certain area without having to rely on that utility grid. So we
Yeah.
can actually play in both spaces as needed. But as you're pointing out, the utility grid is it's under a lot of stress, and as electrification of our world increases, that need for electricity is just going to continue to increase.
Yeah, it is. It's going to grow pretty exponentially, particularly if this effort to scale up electric vehicles becomes a reality, because the load EVs alone are going to put on the grid is really going to be massive. And I just don't think our policymakers have really thought through all these kinds of things, all these kinds of considerations that, of course, it's an overwhelming set of challenges for anyone to be able to think through and plan for. But I just am kind of concerned that we're gonna hit a bit of a crisis here in the coming years with everything that's happening in that space. what about incentives from the government? Speaking of the federal government, we have the IRA, we have the infrastructure bill. There's this, set of billions and billions of dollars in tax incentives and outright subsidies for these kinds of for wind and solar, and a lot of different things. I wonder though, does geothermal qualify for the investment tax credit, for example, or any of the other incentives in those bills?
Yeah, David, for years, wind and solar had a lot of tax incentives that geothermal didn't see. But in the Inflation Reduction Act, there are tax incentives not only for wind and solar, but also for geothermal, and then also for storage. So for the first time, storage tax incentives, you don't have to have storage actually connected to either wind and solar. It can be independently implemented. So yes, there's investment tax credits, and then for storage, there's actually production tax credits in the IRA. So the IRA, of course, everybody's waiting on guidance from the IRA, so it looks great on paper. But yeah, I mean, the incentives are 40, 50, 60% investment tax credits in some areas with, there's additional 10%. It starts kind of at a base of 30%. So there's additional tax credits. For example, if you're in an energy community, which, a lot of the areas that we're looking at are energy communities because they're communities where there's either oil and gas wells, or we're looking at repurposing coal plants. That's considered an energy community. So those additional tax credits would apply.
So how would repurposing a coal plant with geothermal, I mean, what would the mechanics be involved in doing something like that? I know we have a couple of dozen probably retired coal plants here in Texas. So what would the mechanics involved be in doing that?
Well, so first you would want to evaluate whether you can drill to the temperatures that you need for geothermal. So for example, we're targeting 300 degrees F or greater.
Yeah.
If you can, again, if you can economically drill to those depths. If you can't, then what we would want to do, and we're actually working with a coal plant here in Texas, is using our energy storage combined with solar. And so what is attractive about coal plants is that they've already got a lot of infrastructure that we can reuse. So, the simple ones are roads, buildings, but the more complex ones, or I guess the ones that are really fit for what we're doing is, water, surface water facilities for cooling. There's already a substation right there at the power plant, so you don't have to worry about those interconnections and the cost of interconnecting because the infrastructure to the grid is already there.
Yeah. So I guess my understanding of this, so when you bring the heat up out of the ground from a geothermal well, is there any potential for that heat to be transported to another site for power generation, or would the generating capacity need to be right there on site? I wonder about, the need for any kind of pipeline infrastructure related to a geothermal operation.
So ideally, you would want the power generation right there so that you don't have to build the piping. You don't have to, if you can imagine, you're going to have to insulate that piping so you don't lose heat in the transport of the hot water from the well to wherever the power generation is. And so ideally, you're going to want that power generation right there on the well pad.
Yeah.
And because electricity, of course, is going to be easier to then transfer to other places and to utilize. There are direct heat applications, of course, and still, even in the direct heat applications, the closer you are to the end point or the use point, the more ideal it would be.
So I just wrote a story about ESG and emissions, and of course, ESG is a very significant concern for every company in every industry these days. And I wonder about where geothermal is concerned. What are the big challenges your company faces, just in terms of particularly the E piece of it? I mean, every company is, of course, going to want to focus on diversity and proper governance. On the emissions piece of it, is there a significant carbon footprint with a geothermal operation, for example?
Yeah, we caution about saying zero, but it's very, once you get past the drilling of the well and the construction of the power plant, of course, constructing the pad before you even bring the drilling rig out there, that's going to be our biggest carbon footprint is in the construction. And of course, in the oil and gas industry, we can also use rigs that run off of well, typically high line. And there's even some companies that are working on battery storage to run their rigs. So once you get past the construction phase, the carbon footprint goes down considerably. Because we're not using any kind of fuel for our operations. It's any kind of energy that we need, we'll take it out of our operations, for pumping, for example, or for cooling. That will be basically a parasitic load out of the energy that we create. But it's close to zero, David, but we don't like to say zero because that's something that's hard to promise.
Yeah, are you to the point as a company of producing an annual sustainability report? Or have you not gotten to that step yet?
We have not gotten to that step, but let me say, one of our investors actually is Neighbors, and I'm sure you're familiar with Neighbors. Yeah. They're the largest, drilling contractor onshore in the world. And so, as we progress as a company, they've been great to work with. They've been very supportive with their back office. And for example, we have an investor that's asking us exactly what you just asked. What are your scope 1 and scope 2 emissions? And so we have our team working on what do those scope 1 emissions look like. So we're going to be talking to Neighbors this week about what the scope 1 emissions from their drilling rigs look like. But again, they've been great partners to work with, and they've been helping us with those type of reports. And we just haven't gotten there as a company in having to submit those kind of reports as of yet.
Yeah, we talk about footprints and carbon footprint, but there's also, one of the other concerns that inevitably arises with any operation like this is land footprint. And my assumption, of course, is given the similarities to an oil and gas drilling operation, my assumption is that the well pad and the overall land footprint of a geothermal operation is probably pretty similar to that of a typical drill site in the shale patch, correct?
Yeah, David, you're spot on. So on average, it'll depend on the ambient temperature where we're drilling the well, but on average, we're going to get about 3 megawatt net per well. And so if you want to build, say, a 50 megawatt power plant, then what we're going to want to do is drill between 18 and 20 wells, but we're going to use unconventional multi-well pad operations where you space the wells about 10 feet apart on surface, but you directionally drill so that you've got the space and no thermal interference in the subsurface. So for a 50 megawatt power plant with the well footprint and the power plant footprint, you're looking at about 5 acres or less.
That's amazing. That's less, just for folks to understand. That's roughly about the same in a big wind farm as a single turbine is going to occupy, basically, one of the tall towers. So that's a pretty minimal land footprint. All of this to me just makes so much sense. I really hope this is an industry, a piece of the industry that's able to really scale up in the years to come. I wonder, I always like to ask this question, what would you like for our viewers to know that I haven't already asked you about? Because I never think of all the good questions to ask. So, is there something I haven't asked that you want to talk about?
Well, and I think I mentioned in the beginning, geothermal and energy storage. I want to emphasize the energy storage because that is what is needed right now to really complement wind and solar. it's a natural segue from oil and gas. So we use the same equipment, we use the same, professional skill set. So that's what I would want to leave your listeners with is this is a great way for the oil and gas industry to expand, their application, to learn more about renewables and really to get into the renewable space. And it's pretty obvious. We do actually, two of our investors are from the oil and gas industry. One is Neighbors and one is Geolog. And so they recognize that it's a natural segue for not only their people, but their equipment.
Yeah, and the ability to produce a continuous energy storage like you're talking about. Just to give you an example of how little understanding there is of this in the media, late last week I fielded a media call from a publication I won't mention, but the reporter was calling about the potential for energy storage in Texas. And she was looking for somebody to give her obviously very favorable comments about lithium ion stationary storage, and I don't have a positive view of that, so my comments didn't end up in her story. But I did mention the potential for geothermal storage in that interview, and she had literally no idea what it was I was talking about. So that's, of course, a challenge that your industry is going to have to be able to meet. Is a big part of it's going to be educating the public about all this, right?
Yeah, actually, just last week I was in Washington, D.C. The Geothermal Rising Association had scheduled a Capitol fly-in, and the intent was exactly what you're talking about, David, is education. A lot of people don't understand. I mean, and to their defense, when you drill a well, you can't see below the surface, so they don't really
Sure.
understand what's going on